Alright guys, today we are going to be reviewing adding and subtracting fractions. We've done a section on adding fractions with unlike denominators. We've done a section on subtracting fractions with unlike denominators. Now we're going to put it all together and mix them up and just practice and review this. So hopefully this isn't new material, and hopefully you find this pretty simple and fun too. Let's get started. So as my notes say, I want you to make sure that you're watching your signs, whether it's addition or subtraction. They're going to be all mixed up, so it's very important for you to take your time and look at those signs. Also today we're going to be working on simplifying our final answer into the simplest, most reduced form. And if that doesn't sound familiar, then we'll talk about that more when we get to a problem that requires it. Over here in green, I have some steps for you. Get common denominators, solve the problem, simplify. Those are the 3 steps that we're going to be following today to solve these problems. So let's look. 1/6 plus 1/2. Step 1 says I need to get common denominators if I do not already have them. And as I look at that problem, I notice that my denominator, my bottom numbers, are not the same. So I'm going to work to be able to get them. I'm going to count by 6s and I'm going to count by 2s, and I'm going to see what the first number is they have in common. So when I do that, I see that my common denominator is 6. So I'm going to think to myself, how am I going to get a 6 on the bottom of my first fraction? My fraction being 1/6. I think I can multiply it by 1, and it'll give me a fraction that has a denominator of 6. 6 times 1 is 6. Then what? 1 times 1? Well, it's 1. Now I have to do the same thing to get a 6 on the bottom of my second fraction, my 1/2. So in my head, I'm going to think to myself, how do I get that fraction of 1/2 to have a denominator of 6? Let me think. If I count by 2s, how many 2s to get a 6? 2, 4, 6. Ooh! If I count by 2s 3 times, I'll get 6. And I know what I do to my denominator, I have to do to my numerator. So if 2 times 3 gives me a denominator of 6, my numerator, 1 times 3, is 3. So 1 plus 3 is 4, and I keep my denominator the same. Now I look at this fraction, 4/6, and I'm thinking that there's probably a number that I can divide both 4 and 6 by evenly, and that would be simplifying my fraction. So I think to myself, what can I divide both 4 and 6 by evenly besides 1? Ooh, I know. I can divide each of them by 2. Now if I divide my 4 by 2 and my 6 by 2, I'm going to get an equivalent fraction. So 4 divided by 2 is 2, and 6 divided by 2 is 3. So now I have 4/6, but I've simplified it to be 2/3. Now I think, is there any number that I can divide both 2 and 3 by evenly? And the answer is no. All I can divide 2 by is 1, and all I can divide 3 by is 1, and that's not going to change my fraction. So my final answer is 2/3. Let's try another. 1/4 plus 2/5. So try this problem on your own and see how you do. This isn't a new concept, but remember, I want you to get common denominators, solve, and then simplify it. Once you get your answer, see if there's any numbers that you can divide both of them by evenly in order to get an equivalent fraction in simplest form. So when I solved my problem, I got common denominators of 20. I multiplied my first fraction by 5 top and bottom to give me 5 over 20. And I multiplied my second fraction by 4 top and bottom to give me a new fraction of 8 over 20. I added my numerators, 8 plus 5, and gave me a sum of 13. And I kept my denominator the same. So now let's simplify this together. Is there any number that I can divide both 13 and 20 by evenly? Well, 13 I know is a prime number, so that means I can only multiply 1 times 13. Those are the only factors for 13, is 1 and 13. And then my factors for 20 are 1 times 20, 2 times 10, and 4 times 5. So then I'm going to look and I'm going to see what numbers they have in common that I can divide them by. The only number I see is 1. And because they're only divisible by 1, it's going to keep the same number. So 13/20 is in simplest form. Let's try one more problem on our own. 6/11 minus 1/2. So when I do that, I get common denominators, as you can see, of 22. These are my two new fractions that are equivalent to my original fraction. I subtract my numerators, giving me a new fraction of 1 over 22. And there is no number that I can divide both 1 and 22 by evenly besides 1, so this answer is in simplest form.